Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's papers. Students treated a histogram like a bar chart and handed examiners half the marks for free. Imagine getting a histogram question worth 6 marks and then writing frequencies in the bars like their exact values. Ouch. If that sounds familiar, stay with me. This episode fixes that in under 12 minutes.
Wait, so bars aren't like bars? I always thought height equals frequency.
Good question. Let's work through this step by step. At first glance, a histogram looks like a bar chart, but there's a key difference. With a histogram, the area of each bar, not just the height, represents the frequency. Put simply, frequency equals width times height. If class widths vary, height alone lies to you. Let that sink in.
Start with the basics. A histogram has classes along the horizontal axis, for example 0 to 10, 10 to 20, 20 to 30, and the vertical axis shows frequency density. Frequency density is frequency per unit width, so that when you multiply it by the class width, you get the frequency. Practically, frequency density equals frequency divided by class width. Say one class is 0 to 10 with frequency 30, and the next class is 10 to 20 with frequency 15. If you drew equal heights, you'd be wrong, because the first class is twice as wide in frequency terms.
So, frequency density fixes varying widths. But how do I calculate the heights when I draw it?
Exactly. Here's a worked numeric example you can draw on paper as I talk. Imagine 3 classes, 0 to 5 with frequency 10, 5 to 10 with frequency 20, and 10 to 20 with frequency 30. First, find each class width. 0 to 5 is width 5, each height by its class width, and you recover the frequencies. 2 times 5 equals 10, 4 times 5 equals 20, 3 times 10 equals 30. Area equals frequency, always.
One more important point, label your axes. Horizontal axes, class intervals, clearly showing boundaries like 10 to 20, not 10 to 20 something. Vertical axes, frequency density with units. Examiners love tidy labels. It's an easy mark.
What about finding medians or percentiles from grouped data? I usually just take the midpoint and hope for the best.
This is where many students lose accuracy. For grouped data, you use linear interpolation. Think proportional scaling across the class. You do not treat the midpoint as every value. Here's the method. Find the cumulative frequencies up to each class, identify the class containing the median. For the median, that's the n over 2th value. Then interpolate inside that class using frequency density, or equivalently, proportion of the class width. I'll describe the formula in plain words rather than symbols. Take how many values you need into that class, divide by the frequency in that class to get the fraction across the class, then multiply that fraction by the class width and add to the lower class boundary. That gives an estimated median. It's precise, exam-friendly, and repeatable. Example in words. Total frequency n equals 60, so median position is 30th value. If cumulative frequency before the median class is 22, and the median class has frequency 20 and width 8, then you need 30 minus 22 equals 8 more values into the class. Fraction across class equals 8 divided by 20 equals 0.4. So median equals lower boundary plus 0.4 times 8. That equals lower boundary plus 3.2. Simple and defensible on the paper. The examiner can follow your logic and award method marks even if you slip a decimal.
Nice. So write the setup and you can get method marks even if the arithmetic slips. Sounds like a lifesaver.
Exactly. Now let's talk marking. Exam technique, when a histogram question appears, you'll usually see marks split between calculating frequency density,
plotting or sketching the histogram correctly, and answering questions like finding medians or percentiles from it. Typical marking, M1 for correct method setting, for instance showing frequency density equals frequency divided by width, M1 for correct plotting or labelling, and A1 for the final answer correctly calculated and justified. If you write height equals frequency without dividing by width, you lose that first method mark immediately.
Common mistakes that lose marks. Using midpoints as exact values without stating interpolation. Failing to label axes or use class boundaries, and not showing the density calculation. What to write to claim marks. Always show one line of working where you compute density for at least one class. For example, frequency density for 10 to 20 equals 30 divided by 10 equals 3. Then sketch the histogram with the vertical axis labelled frequency density. For medians, write the interpolation setup. Median position equals n over 2 equals 30. Cumulative before class equals 22. Need 8. Fraction equals 8 over 20. Median equals lower boundary plus 8 over 20 times width equals. Write it out and the examiner will give you M marks for method even before the final arithmetic.
That feels doable in an exam, but what's a quick habit I can use every time so I don't lose silly marks? Quick win. A 10-second routine you can use every practice question and exam. First, check that total area equals total frequency. Do the quick sum, add frequencies, and separately compute sum of density times width. They must match. Second, whenever you estimate a median or percentile, write the interpolation setup as a one-liner. Position, cumulative before class, needed inside class, fraction, then compute. Third, a memory hook to beat the midpoint trap. Repeat to yourself in the exam, area counts, midpoints don't. Say it once before you write anything on the paper. That 3-step routine catches most routine errors.
Here's a tiny script you can scribble and repeat under the clock. Density equals freq divided by width. Plot density. Median equals lower plus needed divided by freq in class times width. 10 seconds to write that and you will look like a pro.
Worked example recap. I'll run through a short exam-style question at exam pace and tell you where the marks are. Read this aloud and draw the tiny sketch if you can. Question. A group dataset has classes 0 to 5, f equals 6, 5 to 10, f equals 9, 10 to 20, f equals 15. Total frequency equals 30. Part A. Draw a histogram. Part B. Estimate the median. Step 1. Compute widths. 5, 5, 10. Step 2. Densities. 6 divided by 5 equals 1.2. 9 divided by 5 equals 1.8. 15 divided by 10 equals 1.5. Write one line showing each calculation. That claims M1. Step 3. Draw bars with heights 1.2, 1.8, 1.5 and label vertical axis frequency density. That claims M1 for plotting. Part B. Median position 30 divided by 2 equals 15th value. Cumulative before 10 to 20 is 6 plus 9 equals 15, so the 15th value is exactly at the lower boundary of 10. Write that and you get the A1 for the exact median of 10. A nice clean question where showing your cumulative list earns the marks.
So even if the numbers were less neat, showing the steps would get method marks. I like that.
30-second final check to write on the paper. 1. Label axes. 2. Show one density calculation. 3. Write cumulative table for medians. 4. Check total area equals total frequency. If you have time, substitute your estimated median back into the cumulative to sanity check. Don't skip the check. Examiners love that clarity.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.